Okay. Now one more quantity that they have to study, that is impulse. So whenever a large force acting on a body for a short duration, that effect is known as the impulse. For example, if you are walking on a road and the wheel of vehicle passes over your feet, then what will happen? If we draw the graph versus force and time for that event, so this is your feet here, and the wheel passes over your feet. Then initially force is less and increase, and when the wheel is on the top, force is maximum and then again decrease. Then we can say that force is like this. This is the force time graph that we call FT graph. FT graph. So now if I want to calculate this effect, so basically this is T1 and this is T2. Again, one more graph, that is F versus T. Suppose F is constant. In any other case, suppose F is constant, this is T2 and this is F. What is the definition of impulse? That is force acting on a body for short duration. So impulse is basically denoted by J, and this is equal to F del T. This is the impulse. Now if I want to calculate area under the FT graph, that is area under the FT graph, this is A is equal to, this is F and this is T2 minus T1. So this is T2 minus T1, and T2 minus T1 is del T, and this is area. So area under FT graph represent impulse. This is the impulse. Okay. Now if force is not constant for the interval of time, force is variable, then how we will calculate the area or impulse? Basically area means impulse in the case of FT graph. So for the calculation of area, this particular area, we take a small element and that average force. So impulse or area is equal to, we calculate for this interval, that is F average, or simply we write F into dt. This interval is dt, and we integrate from T1 to T2. This is the area of this FT graph. So in integral form, impulse is basically integration T1 to T2, interval of time on which force is acted on a body, and this is equal to F dt. It's the impulse. Okay. Now we know that F is basically change in momentum per unit time, or rate of change in momentum, or in mathematics we write dp upon dt. So this is J, this is integration dp by dt, dt, this is dt cancel, so this is dp. So limit becomes initial momentum up to final momentum, then J impulse is equal to final momentum minus initial momentum. Now again we define impulse, that impulse is the change in momentum of a body. So change in momentum is the impulse. So we can write now unit, dimension. So unit is same as the momentum, and unit of momentum is kilogram meter per second. Okay, mv basically. Dimension is mlt minus 1. From here we can write Newton second. So whatever you write, Newton second or kilogram meter per second square, that both are same. So unit of impulse is Newton second or kilogram meter per second, or you can easily say that the is same as the momentum. Dimension is mlt minus 1. So how Newton second is kilogram meter per second, we can illustrate here. Newton second, Newton means kilogram meter per second square. This is Newton basically, and this is second. Then this is kilogram meter per second, and this is the same as the momentum. So this is the impulse. Now impulsive force. Impulsive force. Impulsive force. For this graph, this is T and this is F. The force is here, 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 and all the forces are different. Sometimes it appears a small force and large force. So the average force is the impulsive force. So this average force is impulsive force. How we calculate the average force? So here is the F dt, or here is the F dt. Then we can write F is equal to J upon time. This is the average force, and this average force is the impulsive force. How we will calculate? Then we know J is equal to final momentum minus initial momentum. Then we can write is equal to final momentum minus initial momentum upon time. This is the impulsive force. Now, what was the what is the practical observation about impulsive force? One is the famous example that whenever a cricketer catches the balls, he take his hand in backward direction. So here is a ball, and its velocity is v, and here is the hand of cricketer. A ball moves here, its momentum is very high, and it collide with the hand, its momentum becomes 0. So now we can write, this is suppose 0. Or we can write 100 gram, suppose 100 gram, and velocity is 40. Then what will be the momentum? This is 0.1 into 40, 400. This is 40 kilogram meter per second. Okay, and its momentum here is 0, that is final momentum is 0. Then how much momentum is changed? That is 40. For a short time, that time interval is suppose 0.1 second. In 0.1 second, momentum of this ball becomes 0, and change in momentum is 40. Okay, then how much is the impulsive force? Change in momentum upon 0.1, that is 400 Newton. Okay, now if cricketer bring his hand in backward direction like this, then what will happen? Its momentum is again 0, but there is a more time compared to 0.1. Now suppose this is take 1 second to make the momentum 0 of the ball. Then what will be the impulsive force? This is change in momentum is again 40, because here is the momentum is 40, and after catching the ball momentum becomes 0. Then change in momentum is again 40, but time is 1 second. Then what will happen? 40 Newton. And here force is 400 Newton, here force is 40 Newton. Then avoid the injury, whatever be the. Okay. So this is the examples of impulsive force. One more, that one person jump on cemented surface and one person jump on a sand. Suppose here velocity, this is the mass of 50 kg of the man, the 50 kg of the man, and here momentum is 0. What will be the momentum before coming at the ground? So this is 50, now velocity is suppose 10, okay, 10 meter per second, then momentum is 500. Here momentum is 500. Okay, when the man reach at the surface, then what will be the momentum? 0. Momentum 0. Then change in momentum is here 500. Here change in momentum is 500. Okay, one thing, what's about time? So cemented surface is so hard and it will take less time to change the momentum up to 500 to 0. So this is suppose 0.1 second. So force is 5000 Newton. Okay, sand, when man jump here, then it embedded in downward direction and it will take more time compared to the cemented surface. So here impulsive force is change in momentum upon, suppose it will take time 1 second, then force will be 500 Newton. Here is a 5000 Newton on cemented surface and here is 500 Newton. So here there is no injury, chances of no injury, and here is the injury and fate of the man who jumped from here on the cemented surface. So thank you. Okay.